Station 3. So the question is small, but it says which system of equation will yield the same solution as the systems below. All right, so we've got 4 systems down here, and we need to know which one of these 4 has the same solution as x minus y equals 3 and 2x minus 3y equals negative 1. So, all right, here's what I'm seeing is both equations are written in standard form, right, which tells me that we're going to need to use the elimination method to solve this. I mean, you don't have to, but it might be the quickest way to solve this. Okay, the other thing that I'm noticing right now is that both of our x values are positive, right? There's an imaginary plus sign in front of each of these x values, right? And both of our y values are negative. So right now we're not fully, and we're definitely not set up for a zero pair at all. We're going to need to multiply our top equation. I'm going to eliminate x. It doesn't matter what value you eliminate. I'm just going to eliminate it because it's the first one. So I know that in a second, I need to manipulate this equation so that I'm left with a negative 2x in this top equation. Because that negative 2x and this positive 2x here, right, when we combine them together, they become 0 x's. Right? That's our goal. We want to eliminate the x's. So I'm going to multiply this top equation by a negative 2. Right? The bottom equation is already positive, so we need this top equation to be a negative in the second, right, so that we get the zero pair. So that's why I'm choosing to multiply by negative 2. So I already did negative 2 times x for us right here, right? Negative 2 times x. The next thing that we have is a negative y times negative 2, right? There's an imaginary 1 in front of that y, right? It's a negative 1y, negative 1. It is okay to use your calculator and do negative 1 times negative 2 to make sure that we know that we're going to have a positive 2 y's, right? A negative times a negative becomes positive 2 y's, and that's equal to negative 2 times 3. Negative 2 times 3 is a negative 6. Don't forget to multiply by that third term. It's easy to forget. And then we're going to just continue to rewrite the bottom equation, right? Then I have negative 3y's, and then I have that's equal to negative 1. And now I have to solve this, eliminate. I hope I can do this. I don't have much space. All right, these guys make a zero pair, right? Together, 0. Negative 2 and positive 2, 0. They're eliminated. 2 and a negative 3, right, is the same as saying 2 minus 3. That's minus 1. Our answer is a negative 1, right? Or you could have wrote 2 plus negative 3. Right? We're still going to get negative 1 for our answer here, right? So we have a negative 1y is equal to negative 6 and negative 1. Negative 6 and means plus, right? Negative 1 together, they make negative 7. So negative 1y equals negative 7. Remember, we need what y equals, not negative y, y. So let's divide by the coefficient. Sorry, I'm running into the next problem here. Negative 1, divide by negative 1, y equals 7 here, okay? Y equals 7. And then let's put that solution back into, I'm going to put it into the top equation here. So x minus y equals 3. Right? We know what y is equal to. Y is equal to 7. So let's do x minus y, which is worth 7, is equal to 3. You can do this in your head, right? We know the answer is going to be 10. What number, when we take away 7, gives us 3? But just to prove it algebraically, right, we're going to add 7 to both sides to keep it equal. X is equal to 10. Now we've got to figure out which of these equations down here has that solution. All right, let's get it. Let's just go for it. All right, number 1 set up for us beautifully, right? This is already a zero pair right there. So let's go ahead. Hey, wait a minute. Negative 2x Oh, this is a plus 2y and this is a minus 2y. I thought it was the same exact equation. Okay, no, it's not quite the same exact equation. Anyways, okay, 0 pair, gone, right? Negative 2y's and negative 3y's becomes negative 5y's is equal to negative 7. Let's divide by negative 5, divide by negative 5. Y is equal to negative 7 divided by negative 5, 1.4. Y equals 1.4 here. Well, our original problem, y was equal to 7. This cannot possibly be the answer, right? We can stop right here. There's no need to keep going. If we know our y's don't match, this can't be the right system. So let's move on to 2. All right, here's another 0 pair already set up for us, right? So let's just get to it. 2y's and negative 3y's is a negative 1y is equal to 3 and negative 1 is a positive 2, right? It's really just 3 minus 1. Divide by negative 1, divide by negative 1, y equals negative 2. Well, that's not 7, so bam, that can't be the solution either. Next one. I'm actually going to jump to 4 just because 3 does not have a 0 pair created, right? 3 has to be manipulated in some way, right? Both of these are positive and both of these are negative. However, over here when we look at 4, these y's are set up for us. They're already ready to be 0 paired. They're 0, right? So let's just go with this real quick. 3x's and 2x's is 5x's. That's equal to 9 minus 1 is 8, right? Divide by 5, divide by 5. X equals whatever that is. Whatever that is, you know what it's not? It's not 10. We can leave it as a fraction, 8 over 5. X equals 8 over 5 because we know, as just people, 8 over 5 is not equal to 10. That can't be it. I shouldn't have skipped 3. Oh well, let's go back to 3. All right, this should be our solution if I did my math correctly. Now, remember I just said that we do not have a 0 pair created. So I'm going to go ahead, but what I do see is our x's are both 2's, right? So I'm going to multiply the whole entire bottom equation by just a negative 1. And really what that does is that allows me to just change each of the signs, right? 2 times negative 1, I'll even do it on the calc. Well, whatever, I'll leave it like this, right? We're going to multiply the whole bottom equation by negative 1. 2, let me put this here, 2 times negative 1 is a negative 2. I'm going to just put the negative sign in front of that. Right? Negative 3 times negative 1 is a positive 3. And negative 1 times negative 1, negative 1 times negative 1 is a positive 1. The best part about multiplying by negative 1 is all it does is change your symbols. So now we've got that. I'm going to actually erase the parentheses just to show a little, just to make it a little neater. And this is a plus sign, right? Plus. All right, let's do it. This should be our solution. Okay, 2x's minus 2x's, that's 0. That's 0. Negative 2y's plus 3y's becomes 1y, right? Negative 2 plus 3 is 1. So we have 1y, which I'm just going to write it like that. Y equals 6 plus 1 is 7. Y equals 7. Well, look, we had y equals 7 before. We should get x equals 10. We should, but let's just check. I'm going to go with the top equation. So we rewrite the top equation, 2x minus 2y equals 6. Remember, we know what y is worth. Y is worth 7. So let's change that y right there. Let's put it in as a 7, right? So now we start simplifying, right? Negative 2 times a positive 7 is a negative 14, right? We have to leave the 2x and we have to leave the equal 6 for right now. Now our step is, okay, so is there anything to combine? Are there any like terms to combine? I always like to put my lines around my equal sign when it's time to check about combining like terms. There are no like terms to combine right now. So we can just move on to the final step, which is to isolate the variable. So I'm going to add 14 on the left, because this will then disappear because we've created our zero pair, right? But to keep everything equal, we need to add 14 over there. 2x's is equal to 6 plus 14, which is 20, right? Divide by 2, divide by 2. 1x equals 10, which was also part of our original solution. So here, the solution 10, 7 is the same for the original problem and answer number 3.